So scientific notation is a way for scientists to write a number that is very big or very small in an abbreviation. So scientific notation is normally written as a number that is greater than or equal to 1 and less than 10. Normally it can be either a whole number or a decimal of that. It has to be in between 1 and 10. And it's always times 10, that's the base, to the exponent of whatever power that is, and that power can either be positive or negative. Now, this would be an example of a correct scientific notation, because this is 5.9 times 10 to the negative 3. This is within 1 and 10, so it's good. Now, this one would not be correct. It would not be in scientific notation because 0.15 is actually less than 1, and it needs to be greater than 1, greater than or equal to 1, and less than 10. So that's why that would be a no. Now, there's two ways to go about solving scientific notation. You can either go from scientific notation to standard form or standard form to scientific notation. Standard form is when the number is as big or small as it was before, whereas scientific notation is where it's written like this. So if we were converting from scientific notation to standard form, so we're going from this scientific notation and we want to put it into the actual number that it is. If the exponent is negative, you're going to move the decimal point to the left. If the exponent is positive, you're going to move the decimal point to the right. So we're going to take these first 4 examples and we're going to take them from scientific notation and we're going to move them into standard form. So we notice that we have 3.2. So what I'm going to do is I'm going to rewrite 3.2. And it's times 10 to the negative 4. So because it's a negative exponent, I'm going to move it to the left. And this means that it's 10 to the negative 4th, so it's a lot smaller. So if you always think of it, if I went to the right, logically, it couldn't be that number because that would make this like 3. If I moved it to the right, that's going to make that 32,200. So that's not going to work. So we want to make it smaller. So we're going to move it to the right. So what I do is I go to the left, sorry. 1, 2, 3, 4. I'm going to put my decimal there. I'm going to draw in my zeros. Okay. So my final answer is going to be 0.000322 is the number that it actually is. So that is the standard form number. Now this one is 7.9 times 10 to the 6. So what I'm going to do is I'm going to rewrite 7.9. Okay, I'm going to move the decimal 6 spots to the right because I want to make it a larger number. So I'm going to go 1, 2, 3, 4, 5, 6. And I'm going to add 1 0, 2 zeros, 3, 4, 5. So my new number is going to be 7, 9, 0, 0, and I have 5 zeros. I'm going to put my commas in. So it ends up being 7,900,000. So that would be my final answer. So as you can see, scientific notation makes it a shorter process and it's easier to read. Whereas this one's 6 times 10 to the 3rd. So I'm going to write out that 6. And what that means is that decimal is behind that 6. Okay, so it's 6.0, you could say. You could rewrite it as that. And I'm going to move it 3 to the right. So I'm going to go 1, 2, 3. I'm going to add my zeros in. So my new answer is going to be 6 with 3 zeros, which is going to be 6,000. So that is what it is in standard form. Now my last question, I have 9.9 times 10 to the negative 7. So I'm going to rewrite that 9.9. And I move it to the 7 to the left. So I'm going to go 1, 2, 3, 4, 5, 6, 7. I'm going to add my decimal. I'm going to have zeros in all the extra spots. Okay, so my number is going to be point, and I have 1, 2, 3, 4, 5, 6 zeros. 1, 2, 3, 4, 0.5, 6, and 99. So it's 0.00000099 would be my final answer.